Let me ask you something, and I want you to sit with this question for a moment before you scroll past or skip ahead. When you think of the greatest civilizations in human history, the ones that shaped how we eat, how we dress, how we build, how we think, how we measure time, how we perform surgery, how we calculate the stars, how we understand the very atoms that make up existence itself, which names come to mind? Go ahead, say them out loud. Rome, Greece, Egypt, England, France. Now let me ask you something harder. What if I told you that one civilization, ancient, vast, and extraordinary, had already done almost all of it first? What if I told you that this civilization gave the world tools and ideas so fundamental, so deeply woven into the fabric of modern life, that we literally cannot function without them? And yet somehow their name rarely makes it to the top of that list. What if I told you the civilization is still alive? What if I told you it's called India? This is not a story about national pride dressed up in emotion. This is not propaganda. This is not myth. This is a documentary about facts, old facts, uncomfortable facts, facts that have been buried under centuries of colonial storytelling and deliberate forgetting. And I say this as someone who spent years reading, researching, and slowly realizing something that made me genuinely angry. Not at India, but at the world for not talking about India enough. So let's talk. Here is something that should be taught in every school on the planet. There was a time, not in ancient mythology, not in fantasy, but in real, documented, excavated history, when one civilization had clean running water, sophisticated drainage systems, standardized weights and measures, international trade networks, and a written language, while the rest of the known world was figuring out how to keep fire alive. That civilization was located in what is now the Indian subcontinent, and it wasn't a small settlement. It wasn't a village of curious people stumbling onto ideas by accident. It was a vast, organized, deeply intelligent society, the Indus Valley Civilization, that stretched across millions of square kilometers and housed populations that would rival modern cities. Let that land in. While other parts of the world were still working out basic survival, the people of Mohenjo-Daro and Harappa were building two-story homes with indoor plumbing. Indoor plumbing, 5,000 years ago. The toilets in those homes were connected to terracotta pipes. Those pipes carried waste away from the house, through the streets, and into what we would today call a septic system. From time to time, that waste was collected and used as agricultural fertilizer. A closed-loop sustainable sanitation system that modern environmentalists are only now trying to recreate. Compare that to medieval Europe, roughly 500 to 1,000 years ago, where human waste was dumped directly onto the streets, where castle toilets were holes in the upper floors of buildings, and a servant, a real, living human being, was stationed below to deal with what fell, where even the Romans, celebrated endlessly for their so-called civilization, made people share a communal sponge on a stick to clean themselves, dunked in vinegar between uses. A shared sponge in vinegar, and India, 5,000 years before even that, had already moved past all of it. The question is not why India was so advanced. The question is why no one seems to want to talk about it. Let's start with something that the whole world loves but almost nobody credits correctly. Diamonds. Right now, today, the global diamond industry is worth hundreds of billions of dollars. Diamonds sit on engagement rings, royal crowns, and museum displays. They are symbols of wealth, love, and permanence. Entire countries have fought wars over them. Entire economies are built around them. And the world's first diamonds came from India, not from Africa, not from Russia, not from anywhere in the Western Hemisphere, from India, for centuries. Not decades, not years, but centuries. India was the only place on Earth where diamonds could be found and traded. The earliest known diamond trade in recorded history happened in India, going back at least to the 4th century before the Common Era. That is more than 2,400 years ago. 2,400 years. During that entire period, India was supplying the world with one of the most precious materials on Earth. Indian merchants knew how to find diamonds, cut them, trade them, and value them. This knowledge was Indian. This industry was Indian. This history is Indian. Then, in the early 1700s, Diamonds were discovered in Brazil. Then in the late 1800s, enormous deposits were found across Africa. And suddenly the entire global diamond trade shifted. New players entered, new powers took control, and the story of where diamonds actually came from began to fade from the world's memory. Here is a fact worth holding on to. Any diamond on Earth that is older than 400 years sitting in a museum, locked in a vault, displayed in a royal palace, that diamond came from India. This one is almost funny, almost. Right now, wherever you are, there is a very good chance you are wearing something with a button on it. A shirt, a jacket, a pair of pants. Buttons are so ordinary, so unremarkable, so completely invisible in daily life that nobody thinks about them. Nobody wonders where they came from or who invented them, but someone did invent them, and that someone was in India. Archaeologists excavating the ruins of the Indus Valley Civilization found buttons, real buttons with holes drilled through them, made from carefully carved seashells. These buttons had decorative symbols on them. They were precise. They were deliberate. They were not accidents. At first, they were worn as ornaments, beautiful objects pressed against cloth or skin. But gradually, people began threading cord through those tiny holes and using the buttons to fasten their clothes together. A simple idea, a revolutionary idea. The global fashion industry today, the combined value of clothing, accessories, textiles, and everything that hangs on a human body, is estimated at over $1 trillion. And the humble button, one of fashion's most essential tools, was born in a civilization that flourished on the Indian subcontinent thousands of years ago. Nobody puts that in the textbooks. Nobody says it at fashion weeks in Paris or Milan. But it's true, and truth doesn't need a runway. Sugar. Think about what sugar has done to the human world. It changed trade routes. It started wars. It fueled colonialism. It transformed cuisine across every culture on Earth. It became an addiction, a currency, a symbol of luxury, and then of everyday life. Today, it is in almost every processed food consumed by billions of people daily. And the technique for turning raw sugar cane into crystallized sugar, the process that made all of this possible, was developed in India. Before this discovery, people who wanted sweetness would simply chew on raw sugarcane stalks. The juice was sweet, yes, but it spoiled quickly. It could not be stored, traded, or transported in any meaningful way. It was local and temporary. Then, during the Gupta period, a time often called one of India's golden ages, Indian thinkers and craftspeople figured out how to extract, heat, and crystallize sugarcane juice into a form that could be preserved, packaged, and sent across great distances. This changed everything. And the word itself, sugar, carries the fingerprint of its origin. It traces back to the Sanskrit word sharkara, which referred to crystalline candy. From Sanskrit, it moved into Persian, then Arabic, then the languages of Europe, traveling the same trade routes that the substance itself once traveled. The word sugar is, at its root, an Indian word. The next time someone stirs sugar into their tea, somewhere in that simple gesture is a thread connecting back to ancient India. Now this is the part that should make every person who loves engineering feel something deep in their chest. 7,000 years of metalworking. 7,000 years. The earliest evidence of metal craft in the Indian subcontinent comes from Balochistan, where tiny copper beads have been dated back to approximately 6,000 years before the Common Era, 6,000 years before Christ, 6,000 years before the Roman Empire, 6,000 years before almost every civilization that the Western world celebrates as ancient. By the time of the Harappan civilization, which itself is ancient by most standards, the people of the Indus Valley had already mastered the art of metal casting. They were melting gold, silver, lead, copper, and bronze, and shaping them into tools, ornaments, and objects of extraordinary precision. But here is where it gets truly remarkable. The first form of what we now call steel, known historically as Wootz steel, was invented in India. The exact origin is difficult to pin down with precision, but the earliest clear historical reference appears around the time of Alexander the Great's invasion of India. Historical accounts describe the Macedonian conqueror receiving a gift from the Indian king Porus, a gift of around 2.5 tons of this extraordinary Indian steel. Let that image form in the mind. Alexander the Great, one of the most powerful military figures in recorded history, receiving steel as a gift because Indian metallurgy was so advanced, so legendary, that even a world conqueror wanted a piece of it. Wootz steel, it would later emerge, was the secret behind Damascus steel, those legendary blades of the Middle East, famous for being able to slice through silk while simultaneously shattering European iron swords. For centuries, the origin of Damascus steel was a mystery to Western metallurgists. When they finally understood what made it so extraordinary, they discovered something that should have surprised no one who knew Indian history. It wasn't from Damascus at all. The steel was Indian. The crucible method, the high-carbon process, the presence of carbon nanotubes that gave the blades their extraordinary flexibility and edge, all of it traced back to Indian metallurgical techniques developed in the 6th century before the Common Era. When British metallurgists tried to replicate the process in the 1900s, they failed repeatedly over many decades. A technique that Indian craftspeople had developed and refined over centuries could not be reverse engineered by some of the most educated scientists of the industrial era. And then there is the iron pillar. Standing in Delhi, open to the elements, sun, rain, humidity, dust, for 1,600 years without developing significant rust. 1,600 years. Modern science, for a long time, could not fully explain it. Western metallurgists initially dismissed it as luck, as coincidence, as some happy accident of Indian geography. They were wrong, and eventually they were forced to admit it. Analysis of the pillar revealed that ancient Indian smiths had used a technique involving high phosphorus content that created a thin, self-repairing molecular film on the iron surface. It was not luck. It was not accident. It was deliberate, sophisticated chemical engineering, the kind of knowledge that modern metallurgy only began to properly understand in the 20th century. While Europe was in its dark ages, India was creating iron so pure and so protected that it would outlast the civilizations that came to conquer it. Think about that. Somewhere in ancient India, more than 2,500 years ago, a man named Sushruta was doing something that would not be repeated in the Western world for over 1,000 years. He was performing surgery, not butchery, not guesswork, not desperate hacking with crude tools. Actual, documented, systematic, reproducible surgery. His text, the Sushruta Samhita, describes over 300 different medical conditions and the use of more than 120 specialized surgical instruments. The level of anatomical knowledge encoded in that text reflects centuries of careful observation, practice, and refinement. But perhaps the most extraordinary thing Sushruta is documented to have done is this. He performed rhinoplasty, nose reconstruction surgery. In a time and culture where the nose was often cut off as punishment for certain crimes or as a deliberate act of humiliation in battle, Sushruta developed a technique to rebuild it. He would take a flap of living skin from the patient's own forehead, carefully shape it, and graft it onto the side of the missing nose in a way that preserved blood supply and allowed healing. This was not theory. This was practiced. This was refined. This worked. Fast forward to the 1700s. British surgeons working in India witnessed this technique being performed and were so astonished by what they saw that they documented it, brought the method back to Europe, and published descriptions of it in British medical journals. That documentation became the foundation of modern plastic surgery. The entire field of plastic and reconstructive surgery as it exists today, helping burn victims, accident survivors, cancer patients, soldiers wounded in conflict, traces its origins back to a physician in ancient India who was tired of watching people suffer from a wound that others claim was permanent. His name was Sushruta, and the world owes him an acknowledgement it has never properly given. Here is something that sounds impossible. Every computer in the world, your phone, your laptop, the servers that run the internet, the satellites orbiting the Earth right now, speaks one language. It is the simplest language imaginable. It has only two characters, 0 and 1, on and off, yes and no. This language is called binary, and without it, the modern world as we know it simply does not exist. A man in India described this system over 2,000 years ago. His name was Pingala. He lived and worked around the 2nd century BCE, which means he was doing his most important thinking roughly 200 years before the birth of Christ. He was not, by profession, what we would today call a mathematician. He was a scholar of language and poetry, specifically of Sanskrit, the ancient and extraordinarily refined literary language of India. His great project was to understand the rhythms of Sanskrit verse, the way short syllables and long syllables could be arranged in different sequences to create different musical effects, different feelings, different kinds of beauty. This is worth sitting with for a moment. The man who laid the conceptual groundwork for the computer was not trying to build a machine. He was trying to understand a poem. Sanskrit poetry follows strict rules about syllables. A syllable is either short, taking a brief moment to say, or long, taking roughly twice as much time. By combining short and long syllables in different arrangements, Sanskrit poets could create dozens of distinct rhythmic patterns. Pingala wanted to catalog all of these patterns. He wanted a system that could describe every possible combination of short and long sounds. So he invented one. He used two symbols, one for short, one for long. Using just those two symbols, arranged in different sequences, he could describe any rhythmic pattern in existence. The system was clean, complete, and extraordinarily powerful. If you replace his symbol for short with the number 0 and his symbol for long with the number 1, you have binary code. Not a rough version of it, not something similar to it. The same underlying logic, the same essential structure, doing the same fundamental job, representing all possible combinations using only two states. Pingala was writing about poetry, but the mathematics he developed to do it was the mathematics that, 2,000 years later, would teach machines to think. And the binary system was not the only thing he worked out along the way. In the process of counting and organizing these syllable patterns, Pingala described a triangular arrangement of numbers, a grid where each number is the sum of the two numbers above it, spreading downward in a triangle of remarkable mathematical elegance. This structure appears naturally when you start asking questions about combinations. How many ways can you arrange two short syllables and three long ones? How many ways can you arrange four of each? The triangle answers these questions instantly, and it turns out to answer a huge range of other mathematical questions as well. Today it appears in algebra, in probability theory, in the mathematics of chance and statistics, and in many other branches of modern mathematics. In the Western world, this triangle carries the name of Blaise Pascal, a brilliant French mathematician who described it in the 17th century. Pascal was born in 1623 of the Common Era. Pingala described the same triangle roughly 1,800 years before Pascal was born. This is not a small discrepancy. 1,800 years is not a rounding error. It is the entire span from the fall of the Roman Empire to today. It is longer than the existence of most nations on Earth. And yet the triangle is called Pascal's triangle because the history of mathematics has largely been written by people who did not read Sanskrit, did not study Indian scholarship, and did not think to ask what had been discovered in other parts of the world before European mathematicians came along. The same thing happened with binary mathematics more broadly. The scholar who receives credit in Western history for developing binary mathematics, the work that eventually, through a long chain of ideas and inventions, made digital computing possible, is Gottfried Wilhelm Leibniz, a German mathematician and philosopher who did his important work in the late 17th century. Leibniz was a genuine genius, and his contribution was real. But he arrived at binary mathematics nearly 2,000 years after Pingala had already worked out its core logic in a commentary on Sanskrit poetry. There is a certain irony in all of this that is hard to ignore. The West spent centuries portraying itself as the source of reason, science, mathematics, and progress, and portraying India and other non-European civilizations as places that needed to be educated, developed, modernized. Colonial administrators in India spoke of bringing enlightenment to a people who had contributed little to human knowledge. Meanwhile, in ancient manuscripts written in a language those administrators never bothered to learn, sat the foundations of the very technology that would define the modern world. Every time you unlock your phone, You are using a device that depends on binary logic. That logic has a history. It does not begin in a European laboratory in the 17th century. It begins in India 2,000 years ago, with a scholar sitting with a Sanskrit text, listening carefully to the rhythm of the syllables, and asking a simple question: how many patterns are possible, and how do I write them all down? The answer he found changed everything. We just forgot to remember who found it. Before wool dominated European fashion, before synthetic fibers were imagined, before the industrial textile revolution transformed the global economy, there was cotton. And the earliest known evidence for the cultivation of cotton, the oldest cotton fibers yet discovered by archaeologists, comes from Mehrgarh, in what is now Pakistan, dating back approximately 7,000 years. 7,000 years of cotton. The Indus Valley Civilization was farming and weaving cotton on a significant scale around 5,000 years ago. The ancient Greek historian Herodotus, writing in the 5th century before the Common Era, described Indian cotton as a kind of wool that grew on trees because he had no frame of reference for it. Greece did not have cotton. The Mediterranean world did not have cotton. India did, and India was trading it. The Indian textile industry, the art of spinning, weaving, dyeing, and finishing cotton cloth, was so advanced for so long that when British colonial administrators finally moved to dismantle it in order to protect the emerging British textile industry, they were deliberately suppressing something that had been a center of global trade for thousands of years. The famous spinning wheel, the charkha that Mahatma Gandhi would later raise as a symbol of Indian independence, was not a primitive object. It was a sophisticated piece of technology, refined over centuries, that had made Indian cloth the envy of the world. The history books got it wrong, not by accident, not through innocent oversight, but through deliberate choices made by people who understood that controlling the story of the past is one of the most powerful ways to control the possibilities of the future. India's story was stolen from the world's curriculum. Its contributions were credited to others, dismissed as mythology, or simply left out of the conversation entirely. And the consequence of that theft was not just that India was diminished in the world's eyes, it was that the world itself became poorer in its self-understanding. Because when a civilization that gave humanity zero, gave it surgery, gave it the concept of the atom, gave it cotton and steel, and the idea of a university, when that civilization is written out of the story of human progress, the story humanity tells itself about what it is and what it is capable of, becomes fundamentally incomplete. The history of human achievement is not a Western story with occasional contributions from elsewhere. It is a global story built from the knowledge and creativity of every culture that ever grappled seriously with the problems of existence. And India, ancient, deep, brilliant, and still very much alive, is not a footnote in that story. India is one of the story's central chapters. It is time to read it properly. It is time to teach it honestly. It is time to look at a civilization that built indoor plumbing 5,000 years ago, that performed reconstructive surgery 25 centuries ago, that calculated the speed of light 600 years ago, that understood atomic theory 2 millennia before the West formalized it, and to say clearly and without embarrassment or qualification, India did it first, not to diminish anyone else, not to rewrite history with a different bias, but to restore what was there all along. The truth. And the truth is this: somewhere in the distant past, when much of the world was still learning how to organize a village, a civilization on the banks of ancient rivers in the Indian subcontinent was already thinking about the stars, about atoms, about the nature of nothing, about the best way to rebuild a broken nose, about how to keep iron from rusting for 1,000 years. They were already there. They were already doing it. And the world is only now slowly, imperfectly, incompletely beginning to give them the credit they deserved all along. So here is the question to leave with. Not a comfortable one, not an easy one. If a civilization as ancient, as sophisticated, as intellectually extraordinary as India's can be nearly written out of the standard story of human achievement, if contributions this significant can be overlooked, misattributed, or deliberately buried for centuries, then what else does the world not know? What other discoveries, what other ideas, what other chapters of genuine human brilliance are sitting unread in ancient texts, waiting for someone to translate them honestly, and more importantly, Now that India is waking up to its own history, now that a new generation is learning to look at the Iron Pillar, not as a curiosity, but as proof, to read the Sushruta Samhita, not as mythology, but as science, to understand that the zero in their phone's operating system has Sanskrit in its DNA. What will India build next?